So this was a question on mechanics, particularly kinematics and dynamics. The question is asking us to find the acceleration of a car and the constant deceleration force. In fact, the car is decelerating from a speed of 80 kilometers per hour to 0 in a distance of 200 meters. So therefore there is going to be a constant deceleration and there is going to be a decelerating force. So we need to apply Newton's law of motion. So the mass of the car is 1,000. The student had said, according to the question from the student, the mass was 100 kilograms. A car cannot have a mass of 100 kilograms, so I chose to, I took the liberty to make that 1,000 kilogram, which makes more sense, okay? When we ask students questions as teachers, the question has to make sense in the real world. So there is no car that is 100 kilograms. It's more likely to be between 800 and 1,000 kilograms for a small car. So if the mass is 1,000 and the car is moving at 80 kilometers per hour and it is brought to rest in 200 meters, like that, it's coming to rest in 200 meters, then we can determine the deceleration. So it's not actually an acceleration or a positive acceleration, but in fact it is a deceleration, okay? So to find that deceleration, first we must ensure that all the units are SI, okay? So we can see mass is kilogram is SI unit, the distance of 200 meters is SI unit, but the speed of 8 kilometers per hour is not. The unit for velocity is meters per second. So we have to change that to meters per second. To change to meters per second, we just divide by 3.6, and you can see how that comes about, because 80 kilometers per hour is the same as 80, and the kilometer, 1 kilometer there is times 1,000 meters, divide by 1 hour, which is 60 minutes, which is also 3,600 seconds. So if I remove those 3 zeros, I can put a decimal point here, and I have 80 divided by 3.6. This is to say that every time you need to change from kilometers per hour to meters per second, just take your value in kilometers per hour and divide by 3.6, and you get your result in meters per second. In this case, this should turn out to be 22.2. It's a recurring decimal, I think. Please try it out and check that that is true. So that is in fact, the velocity, the 80 kilometers per hour in meters per second is 22.2 meters per second, like that. So now it should be possible for us to calculate both the acceleration and the deceleration and the decelerating force, okay? Let's start with the deceleration. The information we have should be sufficient to help us find the deceleration. So we know the initial velocity. Let me write that here. So V0 is 22.2 meters per second, and final velocity is 0. We also know the distance traveled x, which is 200. So the equation of motion that helps us find this is the equation v squared is V0 squared plus 2ax. So if we are looking for a, then a has to be V0 is 0, so this is going to be minus v squared, so 22.2 squared, okay? Everything divided by, so a over 2x, which is now going to be 400, 2 times 200, because it's 2x, so 400 there. And when we work this out, I can't remember what I got. Let me check, just check this. Okay, so to find the acceleration, the uniform acceleration of motion, as part A of the question is that, if we substitute in the values, we end up with A being negative 1.18 meters per second squared, and that answer is to 3 significant figures, okay? Similarly, to calculate the force, the constant decelerating force, I can do it here, I don't need to do any more typing. The decelerating force by Newton's second law is mass times acceleration. The mass of the car is 1,000. If you choose to maintain the 100 kilogram, well and good, just put 100 kilogram multiplied by the deceleration there, which is 1.18 1, 8, it is negative, and this becomes negative 1, 1, 8, 0, right? That becomes the force, the decelerating force, which is exerted by the brake system, okay? And this is how we work out this question. I hope you understood. Please send me any further questions you might like me to answer for you. So this falls under dynamics and kinematics. The first question here is basically kinematics. And the second one, which now involves force and mass of a body being accelerated. If we involve F and M, then it becomes dynamics, and all of it falls under mechanics, okay? Thank you very much. I'll see you in the next video. I think I have a few more to solve on mechanics. All right, see you in the next video. If you like the video, please consider subscribing and hitting the notification bell so that in case when we create a new video and when we post it, you are able to be notified. Thank you.